So good morning. So today we shall continue the application part of module 1. So in last class we have studied how to find the solution of ordinary differential equations with the help of Laplace transform and inverse Laplace transform, and we have solved some 3 examples. So we shall continue that. We shall solve some more examples. So to solve these differential equations, what we need to remember, you know that the main formula is L of y raised to n of t equal to s power n L of y of t minus s power n minus 1 y of 0 minus s power n minus 2 y dash of 0, and so on. In particularly, you have to remember these 3 formula. L of y dash of t is s into L of y of t minus y of 0, and L of y double dash of t is s square L of y of t minus s into y of 0 minus y dash of 0, and L of y triple dash of t is s cube L of y of t minus s square y of 0 minus s into y dash of 0 minus y double dash of 0. So when we have discussed 3 examples in last class, so we shall solve some more examples in today's class. So see the 4th example, using the Laplace transform, solve x double dash minus 2x dash plus x equal to e power 2 into t with the condition x of 0 equal to 0, x dash of 0 equal to minus 1. You just understand the difference between this particular example and previous example. In previous example, we used to have y double dash minus 2 y dash plus y equal to e raised to t, which means y dash is nothing but dy by dt, where y is dependent variable, t is independent variable. But in this particular example, we have x double dash minus 2 x dash plus x equal to e power 2 into t, which means x dash is dx by dt, x double dash is d square x by dt square. So x is dependent variable and t is independent variable here. So here, so we have to solve this particular equation, means we have to obtain the values for x here. Okay, second order differential equations we have to solve and obtain the values for x. So first we shall write the given equation as it is in terms of t, x double dash of t minus 2x dash of t plus x of t equal to e power 2 into t. Then take L on both sides. Because of this minus and plus, we can separate one by one. That is L of x double dash of t plus 2 into L of x of t plus L of x of t equal to L of e power 2 into t. Then use the formula. You just observe, actually we have formula like L of y double dash of t. L of y double dash of t is s square L of y of t minus s into y of 0 minus y dash of 0. But instead of y, what we have here? Variable x. So in formula also replace y by x. So our formula for L of x double dash of t will be s square L of x of t minus s into x of 0 minus x dash of 0 minus 2 into L of x dash of t is s into L of x of t minus x of 0 plus L of x of t as it is equal to, say right hand side we have Laplace transform of e raised to 2t. So Laplace transform of e raised to 2t is 1 by 2. Then the conditions are x of 0 equal to 0 and x dash of 0 equal to minus 1. We shall substitute these two conditions here. X of 0 will be 0, x dash of 0 is minus 1, minus into minus plus 1, and again here also minus 2 times s into L of x of t minus x of 0 is 0 plus last term as it is L of x of t equal to 1 divided by s minus 2. Now you can see there are 3 terms with L of x of t. One is here, second one is this one, and third one is s square into L of x of t. So we can take L into L of x of t into s square minus 2s plus 1. Okay, plus then remaining term is this plus 1 as it is. We shall write separately equal to right hand side is 1 by s minus 2. Then see this s square minus 2s plus 1 is in the form of a square minus 2ab plus b square, where a is s and b is 1. So we can write in the form of a minus b whole square. So s square minus 2s plus 1 will be s minus 1 whole square. So we can write L of x of t into s minus 1 whole square equal to 1 by s minus 2. Take this constant term right hand side. That is 1 by s minus 2 minus 1. So if I take s minus 2 as LCM, numerator will be 1 minus s minus 2, or that will be 3 minus s divided by s minus 2. Then see this coefficient of this L of x of t. Take that term to right hand side, which gives L of x of t equal to 3 minus s divided by s minus 1 whole square into s minus 2. So this is for which value? Laplace transform of x of t equal to 3 minus s divided by s minus 1 whole square into s minus 2. But what about x of t? So what we need to do? Take L this side, or taking inverse Laplace transform, then we get equation 1. X of t equal to L inverse of 3 minus s divided by s minus 1 whole square into s minus 2. Now again same thing we have discussed in the last class. If you have these type of terms, how to solve and which method to adopt. So you can see here in denominator there are two terms and one product which consists of two terms, that is one is s minus 1 whole square, second one is s minus 2. So which method we can follow? You have two options. One is partial fraction, because you have a product in the denominator, we can use partial fraction to separate this product, and second one is we can use convolution theorem. Okay, because we can express this term as product of two functions f bar of s and g bar of s. So but here we shall take partial fraction only. So 3 minus s divided by s minus 1 whole square into s minus 2 can be written as a by s minus 1 plus b by s minus 1 whole square plus c by s minus 2. Why it is s minus 1 whole square? Because s minus 1 is repeated two times. Okay, then a by first term, b by repeated term. Then multiply this complete equation by LHS denominator of this LHS. Then left hand side we have 3 minus s, right hand side multiply first term by denominator, you get a into s minus 1 s minus 2 plus b into, you can cancel s minus 1 whole square, remaining term is s minus 2, and third one is we can cancel s minus 2, remaining term is s minus 1 whole square. Then we shall take some values for s. Same procedure, we have solved so many examples of this partial fraction. Same method you can use. So if you put s equal to 1, we can make first and last term a and c term 0, hence we can find b value. Therefore left hand side 3 minus 1 is 2, right hand side is 0, second term is b into s minus 2, that is 1 minus 2 will be minus 1 into b plus 0. Therefore b equal to how much? Minus 2. Similarly, to find c value, we can substitute 2. If you substitute 2, first and second terms will be 0. Then 1 equal to 0 plus 0 plus c. Therefore c equal to how much? 1. Now remaining term is a, but we cannot substitute any value to make b and c equal to 0. But we know the value of b and c, so what we can do? Substitute s equal to 0. So if you substitute s equal to 0, then we get 3 minus 0 is 3, right hand side 2 times a minus 2 times b plus c. But we know the value of b and c, b equal to how much? Minus 2, c is 1. Therefore if you substitute these two values here, we get a equal to minus 1. Therefore a equal to minus 1, b equal to minus 2, and c equal to 1 are the values of a, b, c. Now substitute these values here, which gives minus 1 by s minus 1 minus 2 by s minus 1 whole square plus 1 by s minus 2. Now we have separated this product into individual single term. Then take inverse on both sides. Therefore equation 1 is L inverse of 3 minus s divided by s minus 1 whole square into s minus 2 will be minus of L inverse of 1 by s minus 1 minus 2 into L inverse of 1 by s minus 1 whole square plus L inverse of 1 by s minus 2. See the first term 1 by s minus 1 is e raised to t. Second term, okay, third term also we can solve e raised to 2t, but second term what happened? In denominator is in the form of perfect square. So how will you convert s minus 1 to s by multiplying this complete equation by e raised to t. E raised to t into L inverse of 1 by s square. So L inverse of 1 by s square is how much? T. Therefore our final answer for x equal to x is minus e raised to t minus 2 into t into e power t plus e raised to 2 into t. Correct? So remember, whatever may be the given variable, you should understand how to apply the formula when the variables are y and t and when the variables are x and t. Sometimes they may give in terms of y and x also. That time also you should be able to write the formula. Okay, so this is the solution of first equation, problem. Similarly, we shall see next one. Using Laplace transform, solve d square y by dt square plus 2 dy by dt minus 3y equal to sine t, given that y equal to 0 and dy by dt equal to 0 when t equal to 0. So one second order differential equation, non-homogeneous differential equation is given under the condition that y equal to 0 when t equal to 0. What do you mean by this? Y equal to 0 and t equal to 0, which means y of 0 is 0, y equal to 0 when t equal to 0, y of t equal to y. So y equal to 0 when t equal to 0 and dy by dt is nothing but y dash of 0 equal to 0. So now we shall write the given differential equation in the standard form as y double dash of t plus 2y dash of t minus 3y of t equal to sine t, with the initial conditions y of 0 equal to 0 and y dash of 0 equal to 0. Then take L on both sides. We get L of y double dash of t plus 2 times L of y dash of t minus 3 into L of y of t equal to L of sine t. Now same thing, what is the formula for L of y double dash of t? That will be s square L of y of t minus s into y of 0 minus y dash of 0. Similarly here 2 is outside. Formula for L of y dash of t is s into L of y of t minus y of 0 minus 3 into this L of y of t as it is, because it is not in derivative. Right hand side, L of sine t is there. Laplace transform of sine t is 1 divided by s square plus 1. Okay. Now we shall substitute the conditions. Y of 0 and y dash of 0 both are 0. So you will get this term as 0 minus 0. Here also y of 0 will be 0 and remaining terms as it is. Now if you see here L of y of t, here also we have L of y of t, and in last term also we have L of y of t. So if you take L of y of t common, remaining terms are s square plus 2s minus 3, that is equal to 1 divided by s square plus 1. Or you can factorize this. S square plus 2s minus 3 can be factorized as s minus 1 into s plus 3. Therefore L of y of t will be 1 by s square plus 1 into s minus 1 s plus 3. Correct? See, that's what I told you. If quadratic equation, cubic equation comes, then try to factorize. If you can't factorize, okay, then keep as it is. Otherwise you should try to factorize, because if you factorize, then method will be easy to obtain the result. So L of y of t is this much, therefore y of t will be L inverse of 1 divided by s square plus 1 s minus 1 s plus 3. Again, how will you find L inverse of this? We can use partial fraction. Because there is a product of three different terms, we can separate this product by applying partial fraction. So 1 divided by s square plus 1 into s minus 1 s plus 3 will be as plus b divided by s square 1. Why it is as plus b? I told you. Third type of partial fraction. Denominator you have quadratic term s square power to s. Then you have to write as plus b. Second and third we don't have repeated terms here. So c by s minus 1 plus d by s plus 3. Then multiply complete equation by denominator of LHS. Then we get 1 equal to as plus b. Here remaining term is s minus 1 into s plus 3 plus c into remaining term is s square plus 1 s plus 3 plus d into remaining term is s square plus 1 into s minus 1. Okay. Next step, you have to find a, b, c and d value by taking some values for s. So if you take s equal to 1, we can find C value. Then left hand side is 1, first term is 0, C into 8 plus last term is also 0. Therefore C equal to how much? 1 by 8. Similarly, if you take S equal to minus 3, you can reduce first and second term to 0. Hence we can obtain the value of D. So when S equal to minus 3, left hand side is 1, right hand side first two terms are 0, last term is D into minus 40. Therefore D equal to how much? Minus 1 by 40. Then remaining term is B and A. So we cannot find those values by reducing C and D to 0. So what we can do, you know that we shall try with S equal to 0. So if you take S equal to 0, then left hand side is 1, right hand side A term will be 0 and B term is minus 3 into B, C term is 3 into C, and D term is minus 1 into D. But you know the value of C and D. So if you substitute C and D, then we can get B equal to minus 1 by 5. Still one more values remaining, A value. Now we cannot put any other values here. So in that case, you have studied what we can do, equating the coefficients of S cube on both sides, which means coefficient of S cube is here A S S, S square into S is S cube. Coefficient of S cube, highest power is S cube here. Here also C S square into S. Coefficient of S cube is C. Here also coefficient of S cube is D. So right hand side coefficient of S cube is A plus C plus D. Left hand side we don't have S cube, the coefficient is 0. So then A equal to minus C minus D equal to minus 1 by 10. So A equal to minus 1 by 10, B equal to minus 1 by 5, C equal to 1 by 8, D equal to minus 1 by 40. Correct? Then substitute all these values here, then you get 1 by S square plus 1, S minus 1, S plus 3 equal to how much? Minus 10, minus 1 by 10 into S minus 1 by 5 divided by S square plus 1. That is first one, AS plus B plus C by S minus 1 is 1 by 8 divided by S minus 1 plus D by S plus 3 is minus 1 by 40 divided by S plus 3. Then you can observe there are two different terms in the numerator. So you can separate it, minus 1 by 10 into S by S square plus 1 minus 1 by 5 into 1 by S square plus 1. Here also 1 by 8 into 1 by S minus 1 minus 1 by 40 into 1 by S plus 3. So we have converted this product into single term. Then take inverse on both sides. L inverse of 1 by S square plus 1 S minus 1 S plus 3 will be minus 1 by 10 L inverse of S by S square plus 1 minus 1 by 5 into L inverse of 1 by S square plus 1 plus 1 by 8 into L inverse of 1 by S minus 1 minus 1 by 40 into L inverse of 1 by S plus 3. So you can write the answer. L inverse of S by S square plus 1 is cos t, L inverse of 1 by S square plus 1 is sin t, and L inverse of 1 by S minus 1 is e raised to t, and last one is L inverse of 1 by S plus 3 is e raised to minus 3 into t. So which is the required answer for y? So this is the required answer for the given differential equation. Okay. See, whatever examples we have solved till now, in all examples we are using partial fraction method while finding inverse Laplace transform. Okay. Similarly, one more example we'll see. Solve y double dash plus 6y dash plus 9y equal to 12t square into e raised to minus 3t, subject to the conditions y of 0 equal to 0 and y dash of 0 equal to 0 by using Laplace transform. Same method we have to follow here. Y double dash of t plus 6y dash of t plus 9y of t equal to 12t square into e raised to minus 3t, or 12 e raised to minus 3t into t square, because it's a product we can interchange e raised to minus 3t into t square. Then taking L on both sides, L of y double dash of t plus 6 into L of y dash of t plus 9 into L of y of t equal to 12 into L of e raised to minus 3t into t square. So formula for L of y double dash of t is same thing, s square into L of y of t minus s into y of 0 minus y dash of 0 plus 6 into L of y dash of t is s into L of y of t minus y0, and last term as it is. Right hand side you just see now. You have to be very careful now to solve these type of example. There is a product of two terms. So t square and this t square is multiplied by e raised to minus 3t. If some function is multiplied by exponential term, which property we have to use? The shifting property. Yes or no? E raised to minus 80 into f of t. Then you have to find L of f of t. Then in that L of f of t, replace s by s plus a. So here f of t is t square. L of t square is 2 divided by s cube. Correct? After finding L of t square, replace s by s plus 3 because e raised to minus 80, a value is 3. So replace s by s plus 3 here, which gives 2 divided by s plus 3 whole cube. 2 into this 12 will be 24 divided by s plus 3 whole cube. So which property we are using here? The first shifting property in first part of this module. Then substitute the conditions y of 0 and y dash of 0. Both are 0 here. So remaining terms will be L of y of t into s square plus 6s plus 9 equal to 24 divided by s plus 3 whole cube. Or this s square plus 6s plus 9 can be factorized as s plus 3 into s plus 3 or s plus 3 whole square. A square plus 2ab plus b square will be a plus b whole square. Right hand side also 24 by s plus 3 whole cube. Now if you keep L of y of t left hand side, right hand side this term will be 24 divided by s plus 3 whole power 5. Then how will you find y of t? Y of t is L inverse of 24 divided by s plus 3 raised to 5. Again you just think now. How will you find inverse of this? Do we need partial fraction? No, because we don't have a product here. Then to solve this, we can apply shifting property reversely because we have only one term with s, that is s plus 3 raised to 5. How will you convert s plus 3 to s? By multiplying this term by e raised to minus 3t. Correct? Completing the square and using shifting property inversely. First part of inverse Laplace transform into L inverse of 1 by reduce s plus 3 to s raised to 5. So this L inverse of 1 by s raised to 5 is nothing but t raised to n minus 1 divided by n minus 1 factorial because 5 is positive integer. After simplification we get, because 4 factorial is 24, remaining term is e raised to minus 3t into t raised to 4, which is the required answer for y of t. See here we are not using partial fraction because it is simple one. Direct method we can use, that is we are using completing the square and shifting property inversely. Similarly, next one is solve by using Laplace transform y double dash of t plus y of t equal to 0, given that y of 0 equal to 2 and y of pi by 2 equal to 1. So this is with different example. Y of 0 is 2 and y of pi by 2 is 1. So first we shall try to solve this. We shall try to obtain the solution for y. So L of y double dash of t plus L of y of t equal to 0 because L of 0 will be 0. Then formula for L of y double dash of t is s square L of y of t minus s into y of 0 minus y dash of 0 plus L of y of t as it is equal to 0. Here you can observe one thing. In all example, whatever example we have solved till now, there we used to have conditions for y of 0 as well as y dash of 0. But in this example, in formula we have y of 0 and y dash of 0. But only y of 0 value is given, that is equal to 2, and y dash of value is not given. So in this case, when y dash of 0 is not given, so let us assume that y dash of 0 equal to some constant a. Later we can find the value of a here. So before solving this, we shall take y dash of 0 equal to a. Then the above equation will be s square L of y of t minus 2s minus a plus L of y of t equal to 0. Or if you take L of y of t common, L of y of t into s square plus 1 equal to 2s plus 5 on right hand side. Therefore, what is the value of L of y of t? L of y of t equal to 2s plus a divided by s square plus 1. Or if you have two terms in the numerator and denominator is in the perfect formula type, then we can separate the numerator. So 2 into L inverse of s by s square plus 1 plus a into L inverse of 1 by s square plus 1. So L inverse of s by s square plus 1 is cos t plus a into L inverse of 1 by s square plus 1 is sin t. Now we can find the value of a because we don't know. This is our substitution. So we can find the value of a with the help of this second condition. Y of pi by 2 equal to 1. What is the meaning of this? Y equal to 1 when t equal to pi by 2. So that we shall use in equation 1. So equation 1 becomes y equal to 1, left hand side is 1, right hand side in place of t substitute pi by 2. 2 cos pi by 2 plus a sin pi by 2. So y of pi by 2 is 1 equal to 2 cos pi by 2. We know that cos of 90 is 0 and sin 90 is 1. So 0 plus a. So a equal to how much? 1 here. Substitute this value of a in equation 1, which gives y of t equal to 2 cos t plus 1 into sin t, which is the final answer of the given differential equation. So remember, in some examples they may not give y dash of 0 value. If they have not given y dash of 0, then assume some values for y dash of 0 like a. After that, with the help of one more condition, we can find the value of a. Okay. So therefore, here in this problem, our final answer is 2 cos t plus sin t, where constant a is given by 1. Therefore, y of t equal to 2 cos t plus sin t. So similarly, we shall solve one more example now. Solve y double dash plus 4y dash plus 3y equal to e raised to minus t with the condition y of 0 equal to 1 and y dash of 0 equal to 1. So by using Laplace transform, we have to solve this. You know that we have solved so many examples. Follow the same procedure here. L of y double dash of t plus 4 into L of y dash of t plus 3 times L of y of t equal to L of e raised to minus t. Then formula for L of y double dash of t is s square L of y of t minus s into y of 0 minus y dash of 0 plus 4 into formula for L of y dash of t is s into L of y of t minus y of 0, and this last term as it is L of y of t into this 3 equal to right hand side Laplace transform of e raised to minus t is 1 by s plus 1. Okay. Now substitute the condition. Y of 0 is how much? Both y of 0 as well as y dash of 0 is 1. So here if you substitute that, s into 1 minus 1, and also here in first term you have L of y of t, here also we have L of y of t, and last term also we have L of y of t. So if you take this L of y of t common, or inside the bracket we have to write s square plus 4s plus 3 minus, here s into y of 0 is 1 minus s minus 1, here y of 0 is 1, that is minus 1 into 4 will be minus 4, that is equal to 1 divided by s plus 1. So s square plus 4s plus 3 into L of y of t is, see here minus s minus 5 is there. We shall take these three terms right hand side. So we get s plus 5 plus 1 by s plus 1. So if you simplify this by taking s plus 1 as LCM, we get s square plus 6s plus 6 divided by s plus 1. Now you can see here left hand side s square plus 4s plus 3 is there. Quadratic equation, we can factorize this term as s plus 1 into s plus 3 into L of y of t equal to s square plus 6s plus 6 divided by s plus 1. Therefore L of y of t equal to s square plus 6s plus 6 divided by s plus 1 whole square into s plus 3. Therefore y of t will be L inverse of s square plus 6s plus 6 divided by s plus 1 whole square into s plus 3. Now you can see here again same case. Here which type of term is present? In denominator we have a product s plus 1 whole square s plus 3. So to separate this product, what we can use? Which method we can use? We can use partial fraction. So s square plus 6s plus 6 divided by s plus 1 whole square into s plus 3 can be written as a divided by s plus 1 plus b divided by s plus 1 whole square plus c divided by s plus 3. Or multiply this complete equation by denominator of LHS, then we get s square plus 6s plus 6. Right hand side is a into s plus 1 s plus 3 plus b into s plus 3 plus c into s plus 1 whole square, which means multiply right hand side also by the denominator of this left hand side. Now find ABC value by substituting some values for s. If you take s equal to minus 1, then we can find the value of b, because a and c value will be 0. Then left hand side is 1 equal to first term is 0, middle term is 2b, third term is 0, which implies b equal to how much? 1 by 2. 1 equal to 2 into b, which implies b equal to 1 by 2. Similarly, put s equal to minus 3. If you put s equal to minus 3, left hand side is minus 3, right hand side is first term is 0, second term is 0, third term is c into minus 3 plus 1. Minus 3 plus 1 is minus 2, whole square will be plus 4, which gives c equal to minus 3 by 4. Now one more term is remaining, a value. So here equating the coefficient of s square, or we can substitute s equal to 0 also here. So now we are equating the coefficient of s square. So left hand side the coefficient of s square is 1, right hand side coefficient of s square is a, because s into s is s square, and last term is s plus 1 whole square. If you expand, you will get s square. So coefficients are a plus c. Therefore a equal to minus c plus 1, that will be 7 by 4. So a equal to 7 by 4, b equal to 1 by 2, c equal to minus 3 by 4. Substitute all these values here, which gives L inverse of 7 by 4 divided by s plus 1 plus 1 by 2 divided by s plus 1 whole square minus 3 by 4 divided by s plus 3, which is equal to 7 by 4 into L inverse of 1 by s plus 1 plus 1 by 2 into L inverse of s plus 1 whole square minus 3 by 4 into L inverse of 1 by s plus 3. So you can write L inverse of 1 by s plus 1 as e raised to minus t, and third term as L inverse of this e raised to minus 3t. So this will be perfect square method. So how will you convert s plus 1 to s? By multiplying by e raised to minus t into L inverse of 1 by s square. So L inverse of 1 by s square is t. So our final answer is 7 by 4 e raised to minus t plus 1 by 2 e raised to minus t into t minus 3 by 4 into e raised to minus 3t. So this is the final answer. Similarly, we can solve remaining example. So this is the last part in this module, that is application, how to solve the solution of ordinary differential equation with the help of Laplace transform and inverse Laplace transform. So altogether how many topics are there? In first part, some basic examples, three properties, and then periodic function property, and then unit step function. And in the second part, you have studied inverse Laplace transform with the help of e raised to minus as f bar of s, and second one is completing the square method, and next one is partial fraction method, and then logarithmic function and inverse function, then how to find out. After using that, we have studied how to apply convolution theorem. Convolution theorem can be used to find inverse Laplace transform of a product of two functions. And last one is application of this Laplace transform and inverse Laplace transform to solve the ordinary differential equations. So these are the some important topics in this module 1. Okay. So and this is the last part, solution of ordinary differential equation. So if you have any doubt, you can ask. Okay, thank you.